All right, we are going to jump into from a sequence. We're now going to deal with what's called a series. That means we're trying to find the sum of a sequence. Okay, so sum becomes one thing that we talk about. So sigma notation is a summation notation, which means you want to find the sum. So this letter here is just saying, okay, find the sum from the first term to the fifth term, including those terms. So how would we do that? Well, before we give you a formula, the old school way is say, all right, let's going to plug in 1. We're going to plug in 2. We're going to plug in 3. We're going to plug in 4. And we're going to plug in 5 to find out these terms, and then we could add them up. Sounds like a great time, right? So I get 5, I get 7, 9, 11, and 13, which adds up to 45. That means the sum of 2n plus 3 turns out to be 45. Now, bonus question, if it's 2n plus 3, what type of equation is it? You're right, it's linear. Yes, because it looks like y equals mx plus b. It just has this weird sigma in front of it. Again, just telling us to find the sum. So that makes this arithmetic. All right, not too shabby, eh? All right, let's try that again. We'll give you another one of these. So first thing we'll point out is that it is arithmetic, right? So that's, I'm going to mark over here arithmetic because you see the one down below here. If your eye is like, whoa, look at that thing. Remember, the only other two things we've done was geometric. So I'm going to put a G down here. We'll point that out again in a second. So we're going to go from 1 the whole way to 7. So let's go 4, 1, minus 2, 2 minus 2, 3 minus 2. All right, so you get the idea. So I'm going to list my numbers here, what they should be. 2, 6, 10, 14, 18, 22, and 26. All right, so what do you add up to? 98. So if we add the first 7 terms, we're going to up at 98. Okay, so you get the idea. Remember, slope is 4. Look at this, right? So that's how I could, once I got the first couple on there, I want you to know how we're doing this, just as a review, but we're going to give you a formula here in just a minute. Remember, all the formulas for this chapter will be given to you. All right, so the next one, notice this one's off a little bit, right? It's geometric, so that's the number one idea, right? Because the variable is in the exponent. So we're multiplying by 2 each time, so that's what's happening. So let's go ahead, let's throw in 0. Okay, so I might do this as a table here. Throw in 0. That means I'm going to get 3, 1, 2, 3, and 4. So we throw in 1. What are we up to? Okay, so 2, it's going to give me 6. And we double that, we're at 12. We double that, we're at 24. And we double that, we're at 48. So really with these, if you can identify that it's geometric, right? We were adding before. Here we're just going to keep multiplying it by 2. If once you get the first 2 or 3 numbers, you're like, oh yeah, that makes sense. All right, did you add it up? I was rambling. Okay, 93. That means the sum of the first 1, 2, 3, 4, 5. So that's where you got to be careful. First 5 terms, 0 to 4 counts as 5 because 0 counts in this sequence. All right, 93. All right, not too bad. All right, here it is. Cat's out of the bag. If we're going to deal with an arithmetic sequence, then if I ask you to find the sum, that's going to be based on a series. So here's the formula that we're going to use. So notice some things that we know. First term. And for all intents and purposes, this is the nth term. This is always going to be for us the last term of the one that we're dealing with. Notice I changed the notation. Okay, this means from the first term to the nth term. Okay, so that capital S means find the sum. N is the number of terms, okay, just like we dealt with a single item as well. So not much has changed except for we need to find some values. All right, so let's take a look at the first one and see what we can fill in to this brand new formula. All right, ready? I can get this to move up just a little bit more. It might look a little bit better. Find the sum of the first 20 terms. Okay, so I want the sum of the first 20. All right, here we go. So that means I want 20 terms divided by 2. I have to take the first term plus the, oh, wait, I need the last term. I'm acting surprised, but I'm not surprised. I knew that was going to happen. So what do I have to do? I have to find out what is a sub 20. You mean from last week? Yeah, from last week. All right, so I need the first term, 55, plus 20 minus 1. What's the common difference here? Oh, minus 6? Cool. All right, so I need 19 times negative 6 plus 55. The 20th term turns out to be negative 59. So negative 59. So if we go ahead and start filling in the equation, and then you'll find out, okay, I need to find something else. So this is kind of that layered look, and this is how typically with your SAT style standardized testing questions, this is what's going to happen. All right, so here's what needs to happen now is actually solve this one. So inside of here, I want to work this out first. 55 plus negative 59, so it's negative 4. We're going to take half of that. So I get 10 times negative 4, so negative 40. So that means if I take the sum of the first 20 terms, I will end up with the number negative 40. Not too bad. All right, so I'm only going to do one of each type, just so you don't have to sit here all day and listen to this. Okay, but here's the same idea, but it's twisted completely around. I'm going to find the sum of the series. Okay, first, second, third, I don't know how many, and the last one. What? So here's what I know so far. The sum of I don't know equals I don't know how many over 2, 8 first term plus 134 last term. So we need to find out the term number. You can totally do this because the last term has a value of 134. The first term is 8 plus we don't know what number, minus 1. And you can figure out that these are increasing by 9. So we're going to solve this thing out, right? You're going to subtract your 8. All right, so we're going to take that. We're going to divide it by 9, divided by 9, and then we're going to do that. So n turns out to be 15. Oh, that's final answer? No. Or as we like to say, nah. So 15 is going right here. So that means I want you to find the sum of the first 15 terms. So here we go. We got 15 divided by 2. You're thinking that's weird. We're going to add together 8 and 134 and then multiply by 7.5. So the sum of the first 15 terms, calculator up, 1,065. All right, so real quick, we might find the sum, the n, sorry, I couldn't speak there for a second. We might be solving for n instead of the actual sum so that we can solve for the sum. So these often have an extra layer. That's why kids hate them. You know what I mean? All right, so that of course is your arithmetic. So let's take a look at geometric. All right, 1 minus r, which is the common ratio. We're going to take that to the nth power. We're going to multiply it by the first term. Okay, so I don't even need the last term. This is pretty cool. All right, so let's take a gander at something we might use for that. Sum of the first 17 terms. Okay. So some things I know, a sub 1. Looks like we're multiplying r is 2. Let me label a couple things here. N is now 17, right? Because we want the sum of 17. So is there anything we don't have? 2. We're going to do 1 minus the rule was 2. We're going to take that to the 17th power. Notice this is an n minus 1 here, so I just want to be careful with that. And it's over top of 1 minus the rule, which was negative 2. Look at that. There is nothing extra to solve for in this problem. Pretty groovy, not going to lie. All right, so we're going to do 2 to the 17th and then 1 minus that. So 2 times 1 minus, this happens to be 131,072. Okay, it's over -1, which means we're just going to change the sign out when we're done with it. -131,071 divided by -1. All right, so the sum of the first 17, remember geometric grow very, very quickly, or they get small very, very quickly. This one is growing because multiplied by 2. And it turns out to be 262,142. All right, so the order does matter. So that's the only thing I'll stop and point out here is I do have to do this power first and 1 minus that. So this is where using that second function and then the negative sign on your calculator is really helpful. That way you don't have to think about changing the signs prior to or doing anything weird. We just take care of it by using the previous answer on your calculator. So second negative, that's your reminder on un calculator. That's Rotolo for calculator. All right, we got one more to get set up here, and you're going to do an awesome job with this. A sub 1, what are you? 160. All right, what's the R value? I know, you really want to say it's what pirates say all the time, but it's not. They say C, because that's where they live. It's 1/2. We're going down by 2, so that means we're talking about 1/2. All right, here's the problem. Oh boy, here we go. I know the last term is 5/64. I know the first term is 160. I know the rule is 1/2. I have no idea what term number this is. So I can layer this up. You're not gonna like it, but hey, it's cool. I still like you. You don't have to get upset. All right, divide by 160. All right, so we got 1 over 2048, and it equals 1/2 to the n minus 1. You're like, hey, Mr. Tulip, what'd you leave that big awkward space there for? Because I'm about to bring in the log or the natural log. I'm going to use natural log because it's faster to write. All right, so that allows me to take this n minus 1, so I can divide by the natural log of 1/2. So n minus 1, you are now equal to 11. So we're going to add 1. So n equals 12. All right, pretty cool. So we have 12, and then we just want to stop and put everything back in so we can figure out what we really, really want out of this whole thing. So that's 160. 1 minus 1/2. We're going to take that to the 12th power over 1 minus 1/2. So we can get our final answer, the sum of the first 12 terms. All right, so make sure we go order of operations. We're going to do 1/2 to the 12th power. We're going to do 1 minus that answer. We do have to multiply by the 160 and then divide it by -0.5. And we should work out decimal this time. -319.92. That's where we're at.